Hello and welcome everyone. I want to spend this video talking about a problem with RAG systems. So RAG, for those of you that don't know, is Retrieval Augmented Generation. Just to give you some context, I have spent the last couple of weeks attending various conferences on natural language processing. So most recently, an event at AWS that was a natural language convention that they hold every year in London, and also an event held by the London AI community that talks about the applications of AI and large language models in enterprises and startups. So having conversed with many engineers, there is a common problem that engineers are running into when they are trying to implement RAG systems in enterprises. And I'm finding that this is creeping up in a lot of my own use cases as well. The problem is the problem of enterprise jargon. Why is enterprise jargon a problem? Well, first of all, you've got to consider what enterprise jargon is. Enterprise jargon is the language used by organizations that usually only makes sense in an internal context. It's usually used to describe proprietary technologies or proprietary processes that are specific to an enterprise, to a given enterprise. As an example, I worked in banking for over a decade, and I worked at 4 different banks. Each bank had their own jargon, and it could be used to describe very similar systems, but each would have their own jargon to describe that system or to describe that process, even though the processes were common across the banks. I remember going back almost 10 years now, working in my first bank, and there was a system that we used to call BDRAS, which was a bad debt reporting system. I commonly saw bad debt reporting systems across all the banks I worked in, but that was the only one that was called BDRAS. So that's an example of enterprise jargon. The issue with enterprise jargon is that a lot of the off-the-shelf models that you will use have not been trained on enterprise jargon. And this isn't a surprise, because the models, if you take GPT-4's OpenAI's GPT-4 model, that was trained on public data. And so are a lot of the models that you see hosted on Hugging Face. And even if they are trained on private internal data sets or proprietary data sets, it's not likely that it would have been trained for the enterprise that you require it for. So enterprise jargon can be a big problem, and it can adversely affect the performance of any RAG systems that you build, because it adversely impacts the ability for a model to retrieve relevant text, or for the pipeline to retrieve relevant text from a knowledge base. In this video, I want to just explore 2 tactics that you can use to overcome the challenge of enterprise jargon. The first tactic is to train your own sentence embedding model. And the second tactic is to use a hybrid search approach. Let's get into the details of these tactics. First, let's talk about training your own sentence embedding model. To understand why this could be helpful, it's first useful to understand what a sentence embedding model actually does for us, especially in the context of a RAG system. A sentence embedding model helps us encode sentences numerically such that we preserve the meaning of those sentences. It's useful for downstream tasks. So if we do this successfully, we can use those sentence embeddings for things like semantic search, which obviously is a key part of a RAG pipeline or a RAG system. If you're dealing with enterprise jargon, the off-the-shelf sentence embedding models that are available to you from places like OpenAI or Hugging Face will not have been trained on your enterprise data. Therefore, if that data is saturated with enterprise jargon, you're not going to be able to capture that in your sentence embeddings, just using off-the-shelf sentence embedding models. Depending on the extent of the jargon and depending on the extent of the knowledge base and the domain, you have two options. You can train a sentence embedding model from scratch, or you can fine-tune an existing one. And obviously there are pros and cons to both of those options. Training a sentence embedding model from scratch is not the easiest thing to do. Just to illustrate this fact, we can look at the All-Mini LM L6 V2 from Hugging Face. If we look at the way this sentence transformer model was trained, we can see that the training data itself consisted of around 1 billion sentence pairs. Obviously, constructing a data set, a training data set of 1 billion observations is going to be time consuming, and the compute resource you'd require to train a sentence transformer model from scratch with a data set that large might be out of reach of a lot of practitioners. The second option is to fine-tune your sentence transformer model. So it's taking a model off the shelf and just adapting it, so fine-tuning it on your enterprise knowledge base or your enterprise data so that you can capture some of that enterprise jargon in the model weights and generate embeddings that are able to semantically encode those enterprise jargons. Fine-tuning the enterprise model would probably require a smaller data set than you would need to train a model from scratch. So it's probably a sensible approach to take initially. Start off by fine-tuning your sentence transformer, and if you can get the required performance by doing that, then you're good to go. However, if you do require an extra boost in performance, then you might look to do something a bit more rigorous by training your sentence transformer from scratch completely. Okay. When you're training or fine-tuning your sentence embedding model, it's important to remember that how you structure your data set is going to be really important. There are numerous ways to structure your data set, and you should be able to see from the table I have on screen now, there are 4 ways of structuring your data set outlined here. But in this short talk, I'm just going to talk about 2 prominent ways, which are the structuring it as a pair of sentences and structuring it as a triplet. So we can go into a bit more detail about both and the pros and cons of both approaches. We'll start off by looking at the pair of sentences approach. As the name suggests, when you structure your data set as a pair of sentences, each observation in the data set is indeed a pair of sentences. And you have a premise, a hypothesis, and then you have a label. And that label is one of 3 categories. It's either neutral, it's either entailment, or it's a contradiction. So that's neutral, entailment, or contradiction. Neutral means that the premise and the hypothesis are not, there's no relation between them really. There's kind of no relationship. They're talking about completely different things. Entailment means that the hypothesis and premise are logically related. I think the way around it goes is that the hypothesis follows on from the premise. And the last category is contradiction, and that's pretty self-explanatory. That's when the premise contradicts the hypothesis. And how we would set up our sentence pairs data set is to have your premise and your hypothesis, which could be constructed from your knowledge base, and then a label. And that label will either be neutral, entailment, or contradiction. All right, so it sounds straightforward so far, but actually in practice, constructing this data set proves to be quite difficult. One of the challenges is generating those labels. If you don't have a lot of resources to hire in a human team to label your sentence pairs data set, then you're going to have to take another approach. And that approach might be to use a powerful large language model, such as OpenAI's GPT-4, to label the data artificially. You can do this actually through few-shot learning. So on screen now, you should see some prompts that I've constructed that demonstrate how you might prompt GPT-4 to label your data that you provide using few-shot learning. The challenge here is obviously that, every time you hit that GPT-4 or GPT 3.5 API, it incurs a cost. So if you've got a very large data set, the cost is going to scale with the number of observations that you're trying to label. Another challenge that you might face if let's say you don't want to go down the artificial intelligence route of labeling, you want to use human annotators, then you have to make sure those human annotators are skilled in actually labeling your observations correctly. And you're going to also incur a cost for using human annotation to label your observations. Just taking a step back to the prompting approach briefly. If you do use the prompt, you need to be very careful about how you're constructing the prompt. Obviously, the way you construct the prompt, if you're calling the OpenAI API, is going to be quite different than if you're using an open source model. Depending on your use case, you may not even be able to use the OpenAI API because there might be some privacy concerns. There might be some specialist domain knowledge, or you might be dealing with intellectual property that you can't share outside of the organization. So you have to leverage you'd have to leverage a private model or a private instance of an open source model to use this labeling approach. And that some organizations aren't set up to do that. It's actually quite hard to get some of the larger open source models, things like Falcon 180B and Llama 270B. It's quite hard to get those running on hardware. If you are constrained in ways that it doesn't make sense to construct your data set as sentence pairs, you could construct your training data set as triplets. Compared to your sentence pairs, your triplet data set is a lot easier to construct because you do not require any labeling of the data. The triplet data set just consists of 3 parts. The first part is your anchor, or as you can see on the screen here, it's labeled as query. This will be your reference sentence. The second part is the positive, or the positive sentence. And this sentence is the sentence that is closest to your anchor or to your reference or query in the embedding space. So the sentence that is mapped closest to your anchor in the embedding space. And last, you've got the third sentence, which is your negative. And this is the sentence that's furthest away from your anchor in the embedding space. In plain English, when we say further or closer away from the anchor, we just mean the sentence that is closest related to the anchor and the sentence that's furthest related to the anchor. Ideally, when you're constructing your triplet data set, you want your positive to be closest or more related to your anchor than your negative sentence. That might sound tricky to construct initially, but we can actually use a heuristic to do this. So constructing your triplet data set can be done with a distance heuristic. How you would do this is you would first select your anchor, which could be, let's just take the first sentence in a document, for example. And then your positive would be the sentence immediately following that. And then finally, you'd select your negative sentence, which would be a random sentence that is some distance away from your anchor. You might, if you have a look at the example I have on screen, you can say the negative sentence is actually selected from the next section of the text. The idea here, or the premise here, is that your anchor is going to be more closely related to the positive because it appears in the same area of the text than it will be the negative. That's the idea. And obviously, sometimes this might not be the case, but the idea is this distance heuristic should work most of the time to construct triplets in the way necessary for training your sentence embedding model. One of the advantages of using the triplet method rather than using sentence pairs is that because you don't have to label your observations, you can construct this data set entirely algorithmically or using the heuristic, which means, it's cheaper to construct the data set. You can just type up a Python script and run that, and that should create your triplet data set. Therefore, it makes sense to go with, if you don't have any training data ready constructed, if you don't have access to huge amounts of resources, or even if you do, it might make sense to, first of all, construct a triplet data set and train your sentence embedding model on that and see how it performs. If it meets your business requirements, then you don't need to go through the trouble of generating sentence pairs. But if it doesn't, then you might want to try sentence pairs as a next result. But again, the same principle follows. You always start off with a simpler, less expensive option and try that and see how it works. And if failing that, then move on to the more expensive option and try that and see if there's an improvement for you. Okay, so just to recap, we've covered the first tactic for resolving the challenge of enterprise jargon. So we've talked about training your own sentence transformer, or sentence embedding model rather. And we've talked about, whether you wish to fine tune an existing sentence embedding model or whether you wish to train a model from scratch. We've identified that training a model from scratch is potentially more expensive, requires larger data sets, and also potentially harder to do because, constructing data sets of that size is always difficult to do. Then we talked about how to construct the training data sets itself. So we talked about two different varieties, although there are more than two options. The two we focused on were sentence pairs and also triplets. We identified that sentence pairs are difficult to construct because they require a label. So you need to label the sentence pairs, and you might do that via human labelers, or you could do that with artificial intelligence using a generative model like GPT-4 or GPT 3.5 Turbo, for example. We also talked about the privacy constraints around that. We mentioned that triplets can be constructed with a distance heuristic, which would be cheaper than using human annotators in the case of constructing the sentence pairs. And we mentioned that, for any approach you take, you always start off with a simpler, least expensive approach and test that, and then move on to the more expensive approach if the simpler approach doesn't meet the requirements. One last thing before we move on from this section is that once you've constructed your data sets, it's important that you perform some kind of manual audit over those data sets. And you can do that by taking a sample of your data and, manually looking through that. You obviously have to do some statistics to guarantee to assess the level of confidence you have in that sample. But yeah, taking a sample of your data set and doing a manual audit is going to be important to validate that you've constructed that data set in the right way. Next, we'll consider the hybrid search approach. And this is our second tactic to overcome the challenge of enterprise jargon. Before proceeding with the second part of this video, I'd like to take this opportunity to make you aware of the course that we're releasing. If you're a data professional, software engineer, career transitioner, or a student looking to break into the field of artificial intelligence, this is just the course for you. You'll gain hands-on skills showing you how to develop large language model powered applications using industry best practices. If you feel like this is something that would interest you, please visit the link in the description to this video and register your interest by joining the waiting list for the course. So let's consider the second tactic we could use to address the issue of enterprise jargon. With our second tactic, we would be using a hybrid search approach. Let's just talk a little bit about what we mean when we say hybrid search approach. Cast your mind back to when we're talking about sentence embeddings and how we are trying to encode semantic meaning numerically using sentence embedding models. The reason we do that is because it's useful downstream for things like semantic search, which is a key part of a RAG system or any retrieval system that you could be building. It turns out that there isn't just, well, if you're not aware, there isn't just one type of retrieval mechanism. So we've talked about embedding retrievers, but there are also retrievers that are what people refer to as traditional retrievers that are based on the frequency of occurrence of certain words. So instead of encoding the semantics or meanings of sentences, you're encoding them based on the frequency of occurrence of words in that sentence or some other type of heuristic of that level. A good example of this is TF-IDF. So I'm not going to go into details about how TF-IDF works in this video, but I will link an article in the description to this video to give you more details about TF-IDF and how that works. Just as a higher level, you should know that, you know, the traditional retrieval methods, or, you know, the TF-IDF style methods, encode sentences based on the frequency of occurrence of words, not the semantic meaning. So we've got two types of methods to encode our sentences. We've got the embedding-based methods, which we'll refer to as the embedding retrieval method. And then we've got the traditional methods, which are the TF-IDF style frequency type methods. So I'll refer to those as traditional methods going forward. It turns out that combining these two methods actually can improve the performance of your RAG system, especially when detecting things like enterprise jargon. To understand this, you've got to understand the nature and context of enterprise jargon. A lot of enterprise jargon is abbreviated. So you will have things I mentioned before, BDRAS, which was a system that I came across in banking a few years ago, well, almost 10 years ago now. BDRAS stands for Bad Debt Reporting Analysis System, BDRAS. So that's an acronym. It's abbreviated. Because a significant amount of enterprise jargon is actually abbreviated, it turns out that traditional methods that are based on frequency of occurrence and actually work based on exact matches or keyword matches work well for pulling out acronyms and abbreviations from knowledge bases. Semantic methods like embedding retrieval don't always work well for this, especially if those initial embedding models haven't been trained on the enterprise jargon or the enterprise documents that we're trying to search. And, you know, we've talked about that in the first half of this video. The key thing here is deciding on a strategy or deciding on a pattern of combining your embedding retriever and your traditional retriever. There are obviously numerous patterns that you can use to combine your embedding and traditional retrievers, but I'm going to talk about 3 patterns in this video. The first one is the two-step pattern. So with a two-step pattern, what you would do is perform the steps sequentially. So you would first use your traditional retriever to broadly select the important documents in your enterprise knowledge base. So that's going to be based on, you know, frequency of occurrence and keyword retrieval. And then you would use your embedding retriever to resort those documents that you've isolated based on similarity, so semantic similarity to the initial query. So you've got your 2 steps. Your traditional retrieval comes first, and then your embedding retrieval comes in second. That's one method of combining those approaches. The second method is to physically or mathematically combine your embeddings from your embedding retriever and your sparse vectors that are the result of your traditional retrieval process. There are actually libraries and products like Pinecone that will give you an API to make those combinations. So you'll combine your sparse vector from your traditional retrieval method and your embedding from your embedding retriever, and you reindex those. And A library like Pinecone can help you search over that shared index, that combined index. And that's another approach for hybrid search. That's another pattern that you can use. So the third pattern is a rule-based pattern. So depending on the type of query that you're getting through, you can direct the query to either use the embedding search or the embedding retrieval, or direct it to use the traditional retrieval method. Obviously, of those three patterns, there are pros and cons to each, and getting into the details of the pros and cons is beyond the scope of what I'm trying to cover in this video. But it very much depends on your domain, which one works best. Sometimes it's not even clear which one you should go with. You will have to experiment with all three approaches to see which one will actually meet the requirements for the application that you're trying to build. Just to summarize what we've covered in the second half of this video, we talked about another tactic to overcome the challenge of enterprise jargon when you're building RAG systems. So the second tactic is to use hybrid search. We highlighted that there are different retrieval methods that you can use. There's an initial focus on embedding retrievers, which use embeddings that encode the semantic meaning of sentences, and then we can perform semantic search over those embeddings. But we can also use traditional retrieval methods, which are based on word frequencies and overlaps and word occurrences. They don't encode the semantic meaning of sentences, but they work really well for detecting things like acronyms because they work on exact keyword search. So we covered 3 different patterns from combining those types of retrievers for hybrid search. So the first pattern we covered was 2-step, where we implement search methods sequentially. The second pattern we explored was to combine the embeddings from the embedding retriever with the sparse vectors from the traditional methods and re-index those so we can search over that new index. So you combine those mathematically and re-index those, and you can search over that new index. And I mentioned that there are software libraries like Pinecone that give you APIs to do this. The third approach we talked about was the rules-based approach, or routing, where we route certain queries to the embedding retriever and certain queries to the traditional retrieval methods based on the domain or the query type that we receive. Now that we've covered some of those tactics, I'd like to just leave with some closing thoughts. When you're building enterprise systems, or when you're building large language model applications or retrieval systems, whatever it may be, machine learning, it's important to realize that a lot of it is going to be experimentation. This is not an exact science. If you're new to artificial intelligence in the applied sense, you have to know that it's not an exact science. We do work off heuristics, but oftentimes you'll find that even if you've applied something in one place, there are subtle changes in the domain in your next place, meaning that that same tactic might not work. So you have to get in the mindset of being able to experiment and fail and try something else. And sometimes, your approach that you initially thought would work turns out to be not very performant, and you have to explore a different option. Hopefully the tactics I've presented to you today have been helpful and have been informative. If they have, please give the video a like, and please subscribe to the channel to get more insights on large language models, artificial intelligence, and data science. If you've used any of the tactics in the video for your own enterprise applications, I would love to hear from you. So please put something in a comment. If you've used tactics I haven't mentioned in the video, I'd like to hear from you as well. Thank you for tuning in, and looking forward to seeing you on the next video.